What else did I do? I mean, let's talk about what I can do to mess with you. There's not that many things I can do. And so you should be able to get essentially all of this right. Okay, well, I could leave off a term on the other end. 1 plus 2 plus 3 plus ... plus, well, what comes right before this, n? What comes right before it would be 1 less than n. So here I go all the way up to here, but I've left off the last term. So that would be 1/2 n squared plus 1/2 n minus n. So this, 1/2 n. So that's all the terms where I take off that last term. There's another way you can do this one, though. This n here is just a symbol for the last number. So here the last number is this. So another approach to this one. So I don't care that so there's an alternate way of doing this. If this is the last term, and up here this is the last term, all I've got to do is I've got to put this in. Since this is the formula, if this is the last term and this is the formula for adding all of them up, and down here this is, I've got this in place of this. So in place of these two things here, I'll put in n minus 1. So another possible answer to this one is that this is equal to 1/2 times, I've got this in place of n. So I'll have n minus 1 squared. So in place of this, I'm putting in n minus 1. In place of this, I'm putting in an n minus 1. So 1/2 times n squared, so it's 1/2 times n minus 1 squared. It's 1/2 times n. So down here it's 1/2 times n minus 1. So this is a different formula that's also correct. So this is, we're getting by substitution. I know some people don't like substitution. Here it is. You can get it this other way, that we have the sum of the first n terms. It's this. So I just have to subtract off the last terms, since I'm leaving that off. Either way is fine. So leaving off terms, leaving off first term, leaving off the last term. What else can I do to you with this one? Yeah.
It says multiplication.
Yeah, there was also, we had, 2 plus 4 plus 6 plus ... plus, this is where it gives it away, 2 times n. So what's happening is we are, this is, we've got 2 times 1 plus 2 times 2, that's what the 4 is, plus 2 times 3. So this last thing is kind of giving it away that that's what's going on, plus ... plus 2 times n. So what's going on here is that this really is 2 times 1 plus 2 plus 3 plus ... plus n. So, and we already have a formula for this. So that's the other thing, is that you can have, here we're going up by 2's, and we're starting off with 2 itself, which is 2 times 1. So the formula is going to be whatever the formula for this is, which is 1/2 n squared plus 1/2 n, and we double that. We multiply by 2 on the outside. So leave a term off, leave off the first few terms, or leave off the last term, or this. I could multiply it by, and if it were to look like this. Say it looks like 3 plus 6 plus 9 plus ... plus 3 times n. Say it looks like that. Then here we're going up by 3s. This looks like 3 times 1. So you have to play it a little bit, but I'm not going to be doing much. And this would be the 6 is 3 times 2. And this 9 is 3 times 3. Plus we go all the way through, and we have 3 times n. So I've got a 1, a 2, a 3. Factor out that first factor of 3, and I'm left with a 1 and a 2 and a 3 and an n. And so, but it's going to be then 1/2 n squared plus 1/2 n times 3. So I'm not, from my point of view, it's, you want to try to figure out what the pattern is. And then the pattern should always come down to being this thing. What about this? Or I tell you what the pattern is. I mean, when we did this one, 1 plus 3 plus 5 plus 7 plus ... plus 2n minus 1. I think when we did this one, I wrote below it what this is. So you don't have to come up with this with your imagination. This is 2 times 1 minus 1. That's this guy. So I wrote this down. Plus, now we're doing this one. 2 times 2 minus 1. That's this guy. And then we did this one. That's 2 times 3. 2 times 3 is 6, minus 1 is 5. Remember, you do the multiplication first. This guy here, so plus 2 times 4, that's 8, minus 1 is 7. Plus ... plus, well, I've already got it written out that way on this last one, 2 times n minus 1. So you look at this and you should not panic. If you have a whole bunch of some number, in this case I have a whole bunch of minus 1, to add them, remember we're trying to add them up. How many minus 1s do I have? I've got, here's a minus 1, and I've got, so you can kind of use these things to count. 1, 2, 3, 4. So I've got 1 minus 1. By the time I get over here, I've got this one plus this one. I've got 2. Then I've got a third one and a fourth one. So by the time I get over here, how many minus 1s do I have? I've got n of them. N minus 1. So I can replace all those, summing up all those minus 1s, it's going to be minus n. And so now that I've done all the minus 1s, what's left? I've got 2 times 1, 2 times 2, 2 times 3. So factor the 2 out, and I'm left with 1 plus 2 plus 3 plus ... plus n. And then minus n. So what are we going to have? We're going to have here 2 times, well, this is our friend, 1/2 n squared plus 1/2 n minus n. So, okay. Yes? So, I mean, I have problems. I look around for other variants, and there aren't a lot. We're going to talk about the division thing in a second. I think you were asking.
I knew the multiplication was on there, but I couldn't remember if we had division or not.
The very last problem was, we had this if I%2, if the remainder was 0, equals, if the remainder was 0, then we did the step. So 4 Did we start at 0 or 1? I don't remember.
The one.
1. I less than or equal to n. I plus plus. Okay, so if this isn't here, how many times are we doing step?
10 times.
Well, in times, right? Did you say in? It sounded like 10. Okay.
10.
Okay, we're doing step in times, so the answer here would be in. We're doing, if this isn't here, the answer would be in. So all this, what this is doing is it's cutting down on the number of times you do step. So and it's cutting it down by half because we're only doing step if what? If the number is even. If I is an even number, then we do step. And then half the numbers are even, so it's it's n over 2. If it were this, what would that do? Yeah, so if you look at these numbers, look at the numbers 1, 2, 3, 4, 5, 6, 7. We're dividing by 3 and taking the remainder. So this guy, when I divide this by 3, the remainder is 0. When I divide this by 3, what's the remainder? 1. Divide this by 3, the remainder will be 2. Divide this by 3, well, the remainder will be 3. But what that means is that there's another thing in there. So you go back to 0 again. So in terms of the remainder, so here we're doing. I should draw a different picture. Here's I, and down here is I percent 3. So I is 1, 2, 3, 4, 5, 6. Here the remainder is 1. 3 divides into here 0 times with a remainder of 1. 3 divides into 2. It doesn't go into 2. It goes in 0 times then with a remainder of 2. 3 goes into 3 once. And what's left over? Nothing. Remainder is 0. Here the remainder is 1 again. 3 divides into 4 once. 1 times 3 is 3, and I subtract, I get a 1. Here the remainder, so it goes 1, 2, 0, 1, 2, 0 over and over again. When I get 1 larger, it's still going to go in just once. 3 goes into 5 just once. 1 times 3 is 3, but when I subtract, I get 2. So notice the pattern. The remainders are 1, 2, 0, 1, 2. But now when I get all the way over to 6, 3 divides into 6 twice. 2 times 3 is 6. There's no remainder. The remainder is 0. So, yeah, 1, 2, 0, 1, 2, 0. What's this next one going to be? It's going to be a 1. Because 3 goes into 7 twice. But twice 3 is 6. 6 from 7 is 1. Yeah, and then when I get to 8, the remainder will be 2. And when I get up to 9, the remainder will be 0 again. Yeah. So it works that way for all numbers you divide by. Obviously, if I'm dividing by 4, the remainders are going to be 1, 2, 3, and 0. Ah. Does this help? I mean, they're just, the number of variations is relatively small. I mean, I can push it and find something else. If you say n equals n divided by 2, you put this in a loop, while n is greater than 0. What do? We do n equals n divided by, so the new n is the old n divided by 2, and then we do the step. This is probably an important one that I haven't, we've actually done when we were doing the binary search. How many times can I divide a number by 2? So I'm tell you what, we'll save this one for next. The answer is this stupid thing that gets written out this way, log to the base 2 of n. What am I asking for? I'm trying to find what exponent do I put on the 2 to give me n. And that's the answer that goes. So we'll talk more about this maybe on Tuesday. The point is that it is a fairly small thing. Yeah, I mean, there's all kinds of things to learn, but in this class, we aren't expecting you to learn everything. Maybe we should start counting how many things there are. But I mean, it's truly, I guarantee it's around 10 things. You have to be able to look at it and decide which of the 10 things to do. So on Tuesday, I'm going to pass out some practice problems. That is, unless you insist, you know how much I love grading? That's the main reason I teach, so I can grade. Well, I mean, grades are important, but so if you want me to grade these things, we'll talk about it. But what I mainly want to do is give you practice for the test. Is the test just going to have math on it? No. I at least partially kept this promise. On Tuesday, I will have graded another quiz or so. I will have a few problems, and I will for you to look at. And I think we were going to have a test on, was it Thursday?
Yes.
Yeah, kind of like a midterm, or there may be like 2 midterms. There'll be this one, and then in a few weeks. I'd like to have 2. I always aspire to have 2 tests during the semester. Yes, sir.
Is the test like on paper, or?
Would you like a part of it on the computer?
I was just like, I mean, it doesn't matter to me either way, but like, I didn't know if like we were gonna like use putty to like write things or.
Yeah, well, I could on a Thursday at least we would be in the other room, and so you could use the you could use the computers in the lab. How's that? Or we could schedule, we could have the lab part on Thursday and the written part on paper on Friday. I'm flexible here. There ought to be I know that I want a written part, and I know that there are people that very much like to do things on the computer. So that would be the way I would do it, is that I schedule it for kind of, we might not take all of both days. Again, we can talk about that on Tuesday. Think about this. And on Tuesday, I will, okay, let me write down all the things I promised you. I'm going to grade another quiz or 2. Aha, that probably means just one. Okay, so grading a quiz. There's going to be some of these math, the runtime problems. So that'll certainly, the runtime problems will certainly be part of a written. And then I will give you my idea for what's going to be on the test, which would be just Thursday or part Thursday and part Friday. Okay. So 3 things I promise you. Let's look at one more runtime thing, and then so the other formula. Yeah, no, I less than. Yeah, I less than or equal to n I plus plus. That's the outside loop. Here's the inside. For I want to get this right. For j less than. So that's an exponent, and it'd be the first to admit, yeah, how do you actually do that in C? C doesn't let you put exponents in like that. But let's live with this, and then we'll talk about how to do that in C. So what's happening when I is 0? So if you're dealing with one of these and you can't tell what's going on, you have to kind of figure out. So the first, if you're given code like this, you have to figure out, what am I adding up? Well, I'm doing something when I is 0. So what we're trying to do is we're trying to figure out what that first term is. What am I adding up when I is 0? So we'll look at that. I equals 0. So I'm going to have 2 to the 0. What is 2 to the 0? It's 1. So this first time through, I've got a 1. How many steps am I going to get? Well, j is 0. 0 is less than 1. I'll get a step. But then I make j 1 larger, and so then j is equal to 1. So I'll get 1 step. Okay, this is now finished. So we go back up and we make I 1 larger. So now I is 1. And so when I come down here, when I is 1, I'm going to have 2 raised to the first power. Well, 2 to the first is just 2. I have 1, 2. So this is going to be the number 2. So when j is 0, I'll get a step. And when j is 1, I'll get a step. And then j becomes 2, and it's no longer left. So I'll get 2 steps. 2 steps. So there's a kind of a pattern here, but we better. So this is now done. We go back. I becomes 1 larger. I is now 2. So j, so we're going to have here, the exponent's going to be a 2. So I've got 2 2's, and I'm doing multiplication. 2 times 2. So what I've got here is a 4. So when j is 0, when j is 2, when j is 3, when j is 0, 1, 2, and 3, I'll get steps. When j becomes 4, here I will get 4 steps. I'll get 4 steps. So that pretty much, then 1 step, 2 steps, 4 steps, it looks like then I'm adding up 1 plus 2 plus 4. These are what? These are the powers. The next time, when we go back up, I becomes 1 larger, so I is now 3. So we'll now have here 2 cubed, that's 2 times 2 times 2, that's 8. We'll get 8 steps. Okay. So we'll be adding up 1 plus 2 plus 3 plus 8 plus ... That's continuing. The very last time through, the very last time, I is going to be equal to n. So we're going to have 2 to the n, and we'll get 2 to the n. So rather than adding up the first n numbers, we're adding up the first, how many terms do we have here? This is 2 to the 0. This is 2 to the first. We're adding up the first n plus 1 powers of 2, and that's equal to, this is this last guy. What's the rule for this? You go 1 larger in the exponent and subtract 1. So for instance, if you have 1 plus 2 plus 4, we're up to 2 squared. So 1 larger would be 2 cubed minus 1. That's 8 minus 1 is 7. Notice what I've got here is 7. And 1 plus 2 plus 4 plus 8, that's 2 cubed here. So let's go 1 larger, it'd be 2 to the 4th minus 1. Well, that's 16, minus 1 is 15. Okay, so this formula works. So how many steps? In general then, so if I'm doing it n times, I'm going to have this many steps. So this is this other formula. This is a way it comes up. This is a way it comes up. Here's another way it might come up. So let me show you an alternative. So to say up here I've got a variable k, I make it equal to 1. So k is 1. Down here I'm going to put an open brace here, and we're going to say for j equals 0, j less than k, j plus plus, we're going to do step. And then we do one other thing. When this for loop finishes, we're going to do k is going to be equal to 2 times k. So k was 1. What's the next k going to be? It'll be twice 1 or 2, right? So when we go back through a second, so k was 1, then k is going to be 2. So we'll get 1 step, we'll get 2 steps. And if k is 2, 2 times 2 is 4. So remember, powers are just multiplying, and so you get each new power by taking the old power and multiplying it by 2. So this k is pretty much, this is 2 to the 0, and then I multiply by 2. Now I have 2 times 1 is 2, so I've got 2 to the 1st. So then we'll get 2 steps. After we do the 2 steps, we go back up. Or we do this, we do the 2 steps, 2 times 2 is 4, so next time 2 we'll get 4. So this kind of hides that exponent. I mean, you don't see the power anymore. But, so for each step of this outside loop, I need to put a closing brace on it. So we're doing 2 things with the outside loop. The outside loop runs the inside loop, and we get a bunch of steps. And then it makes k 1 larger. So the next time we run this inside loop, we'll get we'll get twice as many steps as the thing before it. So we end up. This is also going to be 2 to the n plus 1 minus 1. Okay. We've done enough on this, right? At least I think we've done enough on it. I want to go back, and we were working on something when we got involved with that math.
Can you make that bold?
I could try it. Okay, that might be good. It's certainly going to be good for the next 11 minutes. Okay, so yeah.
Well, those projectors wash the letters out.
Yeah, they do.
Distance becomes really fairly similar between 4 and back.
Yeah, I mean this is much better than nothing, but this is not great. Okay.
That's a lot more.
Very good. We're bold. We'll cross that bridge when we come back to it later. So this is the 201 class, and where we're working right now on this. I'm trying to remember. Oh, we're working on this, the evaluating these expressions. Where is that? There it is, the val expression. And as I recall, something terrible, awful was going on right here at the end. We'd gotten this scan function that I was kind of proud of, and then it didn't work. Yeah, thanks. So scan is doing something real good for us. It's taking the input, we've got the input, and it breaks off. If we had 33 plus 4 times 2 minus 5, it's gonna break off this piece. And the first time we call it, it breaks off this piece here, and then the next time we call it, it's going to get the plus, and the next time we call it, so it gets each item, and we process that item, and then we go back and get the next item. Except ours, and there's two things. So what does scan take for plugins? It takes an expression. So that would be like this, with what at the end we're using a $sign to mean end. So it takes an expression, and the second thing it takes is the address of a variable. We're using this integer variable w, and so if it finds an integer, okay, if it finds so there's two things it's finding. It's finding integers. It's finding integers, and it's finding operators. If you were really doing a complete thing, the other thing that you would have in formulas are variables. So it'd be integers, operators, and variables. But we'll stick, for right now, we'll stick with these two, integers and operators. So if it's just an operator, the value it returns is the operator. If it's, so the integer gets put here if it's an integer, and we return what? We return the, if it's an integer, we return 1,000. That's, I just picked that. So, but that's what, so if the value that's returned is 1,000, then that means there will be an integer stored in V. Otherwise, so the return value, so this is how scan works. The return value is 1,000 if it's an integer, and the integer will be in V. And otherwise, we actually return the code for the operator. Okay, so we either return 1,000 for an integer or the code for the operator. And when we had this program last time and ran it, bad things happened, or rather nothing happened. GCC eval expression, it compiled fine, and then /a.out, and we typed something in like 3 plus 4 $sign. We have to end it with a $sign. That was the condition. And we got that. Very discouraging. And it was right at the end of class, and I was tired. Tell me a little bit, what in this while here, so this the scan is inside of the while. What order are things going to be done in here? We've got an assignment, we've got a function call, we've got this not equal. Well, you're going to do the function call for sure. So that means the function gets called, scan runs, it's going to return a value. In fact, I can tell you what, since we start off with a number, whether it's 3 or 33, the scan is going to be returning 1,000. Okay, great. So now, so this thing here is 1,000. What's the next thing you do? Okay, I've got an equal sign here. Over here, I've got a not equal sign. This equal is what? It's an assignment. Which of these two is going to be done first? I mean, I know what I want to have happen is that I want to save the value that scan returned inside of RT for later use. But the people that wrote C have set things up. I mean, if I do this one, which gets done first? The assignment of the 7 or the plus 8? This is a real easy question, but I want to hear somebody to say it. I've got x equals 7 plus 8. What gets done first, the plus or the assignment, the equal?
Should be the plus.
Yeah, the plus gets done first. And the way that's set up is that this thing, the plus has a higher precedence than the equal, than the assignment. And that's how you want it, because you want the calculations to be done, and then you want the value put into the variable. It makes sense to set things up that way, and that's the designers of C set it up that way. So what's happening here is, yeah, the scan is going to run. The next thing is we're going to compare the 1,000 that it's returning, because it's, remember, the first thing is an integer. We're going to compare that with this dollar sign. Well, the code for a dollar sign is not 1,000. It's some number between 1 and 128. So these things aren't equal. So what value is going to, and not equal corresponds to what value? 0, right? Non-zero is true, 0 is false. And so when we do this comparison, this evaluates to false or 0, and we store a 0 inside of RT. So down here, we come down here and we say, if RT, so remember the last thing we do is this thing here. And so I'm not getting what I want. What I wanted was I wanted a value put into RT, and then I wanted to check whether or not that value was equal to $. So what do we need to do? I put a parenthesis here, and I meant this guy here to be over here, so I'm going to move it now. One simple little movement. So I'm taking it out of here, and I'm putting it back here. There it is. So now what goes on? Now I've got this assignment, it's inside of parentheses. So scan is going to return a value, and since the whole thing is inside parentheses, then we do the assignment. That value is assigned to RT. Last thing we do is we check, is the value we just assigned to RT, is it equal or not? If it's not equal to $, we do everything underneath. Okay, that's real embarrassing. So GCC, this A dot out. So 3 plus 4 $. We found the 3. We found the plus. We found the 4. Okay, if it's more complicated, A dot out, like that one, say 33, well, I don't care, 233 plus 4 times 2 minus $5. There it is. So we find the 233, we find the plus, we find the 4, we find the multiplication, we find the 2, okay. So scan is working, but what we need to do now, and what we're going to be doing is that when we hit an integer, we're going to push it onto the integer stack. When we hit an operator, we have a decision to make each time we hit an operator. Are we going to put it on the stack? Are we going to carry out an operation? And so we'll finish this up, well, I don't know, after I pass back a quiz or two and pass out more runtime homework, and we discuss whether or not we're going to grade it, and we talk about the test, then we'll get back to this, okay. So I will